Hello Bharatians of class 12th, I am Jacinta Santiago. Let us move forward to our today's topic. Coulomb's law. According to this law, the force of interaction between any two point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Let us take 2 point charges, let it be q1 and q2. And if the distance between them is r, then according to Coulomb's law, according to this law, the force of interaction between them will be proportional to the product of the charges, that is q1 into q2, and inversely proportional to the square of the distance between them. From this we get F equals to K q1 q2 upon r square, where K is electrostatic force constant and here you should note that its value depends on the nature of medium separating the charges and on the system of unit. Since its value depends on both nature of the medium and as well as the system of unit used, value of K in CGS system is 1, but if we are going to take its value in SI system, in SI system its value will be given by 9 into 10 to the power 9 Newton meter square per Coulomb square. So from this we get K equals to 1 upon 4 pi epsilon naught, and now here epsilon naught is absolute electrical permittivity of the free space. So from this value of K we can write the first equation as, from equation 1 we will get F equals to 1 upon 4 pi epsilon naught into q1 q2 upon r square, and this is the formula which we get from the Coulomb's law. Now let us study Coulomb's law in vector form. For that, let us take two charges q1 and q2 kept at point A and B, and let their position vectors be R1 and R2. Here R1 is the position vector of charge Q1 and R2 is the position vector of charge Q2. The vector leading from Q1 to Q2 is AB, which can be given by R12 vector R2 minus vector R1. We can also take it from B to A, but for this example I am taking from A to B. As the direction of a vector is specified by a unit vector along the vector, we can write R12 cap equals to vector R12 upon just the magnitude of vector R12. Similarly, for R21 we can write vector R21 upon R21. Here if Q1 and Q2 are the like charges, then definitely they will repel each other in the opposite directions, and if we will take unlike charges, then they will attract each other. For this instance I am taking it as they are repelling each other, that means both the charges are like charges. Then F21 will be the force on Q2 due to Q1. Then, according to Coulomb's law, vector F21 will be given by 1 upon 4 pi epsilon naught into Q1 Q2 upon AB square, which is along AB, or which can be written as vector F21 equals to 1 upon 4 pi epsilon naught into Q1 Q2 upon R square, and this R will be 1 2 to R cap 1 2. This is the required equation. This law is universal law, and if both the charges are positive, then they will repel each other, and if both the charges are unlike, that is if one is positive one is negative, then both will attract each other. Here it should be noted that this equation gives us the force between two charges Q1 and Q2 in vacuum only.